Hi, in this video we will be exploring patterns in data. Pattern recognition is the ability to notice similarities or common differences. Through recognizing patterns, we are able to make predictions and make shortcuts. Pattern recognition is the basis for problem solving and designing algorithms. By using pattern generalization and abstraction, we are able to filter out unnecessary information to solve a problem. This allows us to represent an idea or a process in general terms. For example, perhaps your average Sunday. Pattern recognition can be used by humans or some animals. For example, when dogs are being trained, they soon learn from patterns in their behaviour that are being rewarded. Computers use pattern recognition to identify patterns in numbers, text, and images. This kind of information processing is used in areas such as forensics, for example in fingerprint or photo identification. But for a look at some of our current applications, check out our resources page. These might be useful as examples in your classroom. There are particular stages of pattern identification. We might look at the pattern and distinguish a particular set of attributes such as colour, size, length, and then we extract the features. Lastly, we compare patterns to determine a match or a mismatch. Can you identify some patterns in this picture? If you like, pause the video, take a moment to explore the tiles. We also have a link to an activity below that you might be able to also use with your students. This involves you acting as a detective and matching patterns. Have a reflection on your strategies used. What were they? What worked? What didn't work? In the early years, children begin to recognise patterns through guided play or by exploring patterns in their everyday life or objects. For example, there's patterns in quilt covers, daily routines, or number sequences. Can you think of some patterns that exist in our everyday life? If you know any, let us know below. There are also some great opportunities to explore patterns in music. We like this example by meaningfulmama.com, who uses hearts to represent beats and straws to represent the rhythm. Students can manipulate the straws, but keeping to the principle that there must be 2 counts within a beat. The Z represents a rest. Teachers could also clap rhythms and have students hunt for the visual representation of those patterns. Also, in literacy, students could identify and match the clapping of syllables to words, perhaps those on a topic list or those that are on their own spelling lists. We have some examples here of exploring patterns for the early years. Some could even be adapted for older students by incorporating more intricate patterns and designs. We have some examples where students could identify and match barcodes or QR codes. They could be recreating patterns using attribute blocks. They could be continuing patterns using attribute blocks or creating their own. Students can also explore patterns in numbers. For younger students, they might like to explore numbers using counters and number charts. Pattern recognition can be linked back to data representation by exploring patterns in the presentation of information in graphs. Students can collect their own data and create their own graphs, considering exactly what data they need to get to answer their questions. Students can also explore patterns in data through science experiments. Also, comparing the results of experiments or graphs between peers or as a class will provide opportunities where students can compare and contrast patterns and derive findings together. We like this idea on the top left, where a student has been able to collect their own data about their performance in test scores. This could provide opportunities for students to identify themselves what areas they might like to focus on. Also, for older students, there are some great public data sites which are presented and can be manipulated and explored. For example, there's one on public disease outbreaks across Australia. While recognising patterns is fundamental, so too are the questions we ask, or the questions we get students to think about. Students need to carefully consider the types of data they want to collect. Will it provide them with the information to solve their problem? What is the best way to present the data? Once the data is presented, what does the data tell us and what does it mean? We've put a link to some examples of questions that you might ask in your class. but we'd love to hear some suggestions that you might have yourselves. Thank you.